Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at how to balance redox equations. Redox equations can be balanced in acidic medium as well as in basic medium, especially when the ion electron method is used. So, the question on the board requires us to balance the redox equation using the ion electron method in acidic medium. So there are several steps for balancing the redox equation using the ion electron method, but I'm going to be talking about the steps as I solve this question. The first thing is to look at the chemical species in this equation, both at the reactant side and the product side. You will discover that there are 4 chemical species here, and the 4 chemical species are not identical. Some are similar, but they are not identical. So, we are going to break this redox equation into 2 parts. The ones that are identical are going to be put together. So, we'll break down the redox equation into 2 smaller equations, and these 2 smaller equations are called half equations. Now, NO2 minus is similar to NO3 minus, but they are not identical. So, I would say NO2 minus gives me NO3 minus. And then this is similar to this, so we have Cr2O7 2 minus to give Cr3 plus. So what we have done is that we have successfully split this redox equation into 2 parts, and these 2 parts are called half equations. One of the half equations is oxidation, and the other one is reduction. To find out the one that is oxidation and the one that is reduction, you can take any of the elements and see if there is an increase in oxidation number or there is a decrease. Now recall that oxidation involves an increase in oxidation number, but reduction involves a decrease in oxidation number. Now the oxidation number of nitrogen here in NO2 minus is going to be plus 3. The oxidation number of nitrogen in NO3 minus is going to be plus 5. So what that means is that the oxidation number of nitrogen increases from plus 3 to plus 5. Then what that means is that this half equation is oxidation because it involves an increase in oxidation number, and this half equation automatically becomes reduction. So that settles that. Now the next thing is to ensure that all other atoms that are not oxygen and that are not hydrogen are balanced. There is 1 nitrogen atom here, there is 1 nitrogen atom here, so that is balanced. There are 2 chromium atoms here, there is 1 here, so we have to put 2 here to make it balanced. Now that we have balanced atoms that are neither oxygen nor hydrogen, we can now go ahead to balance oxygen atoms. So we'll start with the oxidation half equation. This is NO2 minus, and this is NO3 minus. On the left hand side, there are 2 oxygen atoms. On the right hand side, there are 3. What that tells you is that there is a deficiency of 1 oxygen atom on this side. And when you are balancing a redox equation in acidic medium, you will add water molecules to the side that is deficient in oxygen atom. Now the left hand side here is deficient in oxygen, and the deficiency is 1. So it means I am going to add 1 molecule of water here, so that the number of oxygen atoms here will be 3. And this is also 3, so oxygen atoms are now balanced. The next thing to do is to balance the hydrogen atoms. Because we've seen that the addition of water to this side has also created a deficiency in hydrogen atoms on both sides. So, what we will do is to add that deficiency as hydrogen ions, H plus, to the other side. So, we have 2 hydrogen atoms on the left hand side, and we're going to add 2 hydrogen ions here. After this is done, you can see clearly at this point that both oxygen and hydrogen atoms are balanced. 3 oxygen atoms on both sides, as well as 2 hydrogen atoms on both sides. Now that this has been done, the next thing will be to balance the charges. So we look at the left-hand side. What is the net charge on the left-hand side? -1 times 1 will give us -1. This is 0. So it means that the net charge on the left-hand side is -1. What is the net charge on the right-hand side? -1 times 1 is -1. Plus 1 times 2 is +2. -1 plus 2 will give us a net charge of +1. So we can see that the charges on both sides are not equal. So we have to balance the charges by adding the appropriate number of electrons. And in balancing the charges, what you do is that you add the appropriate number of electrons to the side that has the greater charge. +1 is greater than -1. So it means we have to add the appropriate number of electrons to the right hand side that will make the net charge on this side to become equal to -1. And what you will do to +1 to become equal to -1 is to add 2 electrons. So we're going to add +2e minus on this side. By doing so, if we decide to now recalculate the net charge on this side, it will be -1 times 1, which is -1, plus 1 times 2, which is +2, -1 times 2, which is -2. +2 we cancel out -2, giving us a net charge of -1. So we see that the charges on both sides are now equal. So it means that for each half equation, there are actually 3 things to do. You have to balance atoms that are neither hydrogen nor oxygen. Then you will balance oxygen and hydrogen atoms, and then you balance the charges. So we can call this equation 1. Everything we have done for this half equation will have to be done for the second one. So bringing down the second half equation, we have Cr2O7 2 minus, and we have 2Cr3 plus. There are 7 oxygen atoms on the left hand side, and there is none on the right hand side. So to make up for this deficiency in oxygen, we'll add 7 molecules of water. By doing so, we now have 7 oxygen atoms on this side. But that has created a deficiency in the number of hydrogen atoms. So there are 14 hydrogen atoms here. And to ensure that hydrogen is balanced on both sides, we add 14 hydrogen ions on this side. So the next thing to do is to find the net charges on both sides. -2 times 1 is -2. Plus 1 times 14 is +14. -2 plus 14 will give us a net charge of +12. Here, +3 times 2 is +6. The net charge on the right hand side is +6. So the next thing to do is to make the charges on both sides equal. So what do we do to +12, which is the greater charge, to become equal to +6? That will be to add 6 electrons here. Because by the time we add 6 electrons here, it will now become -1 times 6, which will be -6, and +12 minus 6 will give us +6. Don't forget, each electron carries a negative charge of -1. So now, we have balance both half equations with respect to the atoms and also with respect to the charges. The next thing we have to do is to ensure that the electrons in both equations are the same. In equation 1, there are 2 electrons. In equation 2, 6 electrons. So, what exactly are we going to do to ensure that the number of electrons in equation 1 is the same as the number of electrons in equation 2? 2 is a factor of 6. So, if you multiply equation 1 by 3, it means that the number of electrons in both equations will be the same. So, what this means is equation 1 multiplied by 3 will give us 3NO2 minus plus 3H2O will give us 3NO3 minus plus 6H plus 6E minus. Now, when you look at both half equations, you can see that the number of electrons are equal. Now we can cancel out the number of electrons. Now that we cancel out the number of electrons, we can now add both equations together to get our final answer. And in doing so, we have to ensure that there is no particular chemical species on the left-hand side that will also be on the right-hand side. Because when you look at the original equation, you discover that there are no 2 chemical species that are identical. They are only similar. So we must ensure that in our final answer that we want to get now, that we do not have any particular chemical species on the left-hand side and also have it on the right-hand side. So let us start by adding both equations together. So this will be Cr2O7 2 minus. Now this is plus 14H plus, but I'm not going to write this here. Why? Because there is H plus on the left side of this equation and there is H plus on the right-hand side of this equation. So to ensure that H plus does not appear on the left as well as on the right, I will have to subtract the smaller one from the bigger one. So the number of H plus here is 14, the number of H plus here is 6, so I will subtract 6 from 14 and that will give me 8. So I'll put 8H plus here and then come and add these ones here. This will be plus 3NO2 minus. I am not going to add these 3 molecules of water here because it's on the left-hand side of this equation and there is also water molecule on the right-hand side of equation 2. So I will leave this and subtract this from here when I get to this point. So I put my arrow sign and this will become 2Cr3 plus 7 minus this 3 here will give me 4H2O and then I'll add this plus 3NO3 minus. And this is the answer to this problem. This is the balanced Redox equation for this. However, to confirm that this answer is correct, there are certain things we can do. We will need to check for the number of atoms on both sides. So, for each of the atoms in this balanced equation, we can check if the number on the left-hand side corresponds to the number on the right-hand side. Also, the charges, the net charge on the left-hand side has to be equal to the net charge on the right-hand side. So this is our final answer, but we want to check if it is correct. So I will list the atoms on the left-hand side as well as the atoms on the right-hand side. Now we have chromium on the left-hand side. This is left-hand side, and this is right-hand side. So we have chromium here. We also have chromium here. We have oxygen here. We have oxygen here. We have hydrogen here, and we also have hydrogen here. We have, on the left-hand side, we have nitrogen. On the right-hand side, we also have nitrogen. And then I'm also going to check if the charges on both sides of the equation are balanced. So let us start. On the left hand side, the number of chromium atoms is 2. So this is 2. The number of chromium atoms here is 2. This is 2. The number of oxygen atoms here is 7. And this is 3 times 2. So 7 plus 6 is 13. The number of oxygen atoms here, 3 times 3 is 9. Plus this 4, that is also 13. The number of hydrogen atoms here on the left hand side is 8. The number of hydrogen atoms here, 4 times 2, is 8. And then for nitrogen atoms, the number of nitrogen atoms on the left hand side is 3. So we put 3 here. And the number of nitrogen atoms on the right hand side is also 3. Now let's come to the charges. For the charges, you have minus 2 plus 1 times 8 and minus 1 times 3. So it means that on the left hand side you have minus 2 plus 1 times 8 is plus 8, minus 1 times 3 will give us minus 3. So the net charge on the left hand side, minus 2 minus 3 is minus 5. Minus 5 plus 8 is plus 3. And then, on the right hand side, we have plus 3 times 2, which is plus 6. We have minus 1 times 3, which is minus 3. So the net charge here is plus 3. So when you look at this, you see clearly that in the answer to the question, which is this, the atoms on both sides of the equation are balanced and the charges are also balanced. Thank you very much for watching and see you in the next lesson.